Okay, we're going to go over problem number 6 on the 2017 geometry exam. Hopefully you did problems 1 through 5. So if you're looking at problem 6, hopefully you tried it already, but I want you to write down these notes that I have prepared. All right? And let's read the question. It says, under which transformation would triangle A prime, B prime, C prime, the image of triangle ABC, not be congruent to triangle ABC? All right? Now, we've talked about in the past what a transformation is. There were 3 rigid motion transformations. The reason we call them rigid motion transformations is because they preserve distance and the image is congruent to the pre-image. Okay? And that word preserve means stay the same. So keep that in mind when thinking about this question. That means whenever you do a rotation or reflection or a translation, the new shape is always going to be exactly like the original shape. Okay, so if you look at our answer choices, a reflection over the y-axis, well, it doesn't matter what you reflected over, the shape is not going to change in terms of size or shape. The rotation, same thing, translation. So our answer is obviously a dilation with a scale factor of 2. The only time a dilation would not change the size and the shape is if it were a scale factor of 1. Okay, so make sure to write those notes down if you want credit for that. All right, looking at number 7 now. Let's look here. It says the diagram below shows 2 similar triangles. Anytime you look at these problems, you should be looking at the information they give you and why are they giving us this information. Okay, so think about that. But the first key word I see is similar. All right, so we have 2 similar triangles. Then down here we see if tangent of theta is equal to 3 over 7, what is the value of x to the nearest 10th? All right, so tangent of theta. So that's theta here, this angle. I want you to write this down, SOHCAHTOA, and I want you to write it like this also. The reason why I write it like this with the letters on top of one another is so we realize that when you do the sign, it's going to be the sign of the angle is equal to the opposite over, right? It just helps to recognize what you actually need to do. Okay. All right, so tangent is going to be TOA, that's going to be this one, so it's dealing with the opposite and adjacent. All right, now it's different here in that they tell you what the ratio is, that 3 over 7. So we don't necessarily know, well, remember, tangent is opposite over adjacent. So I can actually label these sides based on this angle. This is going to be my opposite side. So I can label that as 3. My adjacent side is going to be over here, right? And so that's going to be 7. And then my hypotenuse is down here. I'm not sure if we're going to need to find a hypotenuse for this problem, but we'll see. Now, just a little note. When you see the 3 over 7, that doesn't mean that the actual lengths are 3 over 7. What that means is that the ratio of the opposite side to the adjacent side is 3 to 7. So we could actually put 6 and 14 here, and it wouldn't change our answer at the end. Okay, but it says if tangent theta equals 3 over 7, what is the value of x? So x is over here. Now, keep in mind we have similar triangles. So that means that, remember when we have similar triangles, that the sides are proportional and the angles are the same. All right, the angles are congruent and the sides are proportional. So we can actually set up a proportion here. So we can do 3 over 7. So that's this side over this side. The 3 is corresponding to the 2.4. So it's 2.4 divided by the x is what we're looking for. And there are a number of other proportions you could set up, but this is one of them. So we're going to set this up, and we're going to have 3x is equal to 7 times 2.4. I believe that's 16.8. And then we divide by 3, and you end up with 5.6, right? 5.6. We get x is equal to 5.6. All right? Make sure and write that stuff down. Okay, looking at number 8 on the exam, it says a farmer has 64 feet of fence to enclose a rectangular vegetable garden. Which dimensions would result in the biggest area for the garden? All right. When you're looking at fencing, whenever you're looking at fencing, you have to start thinking about perimeter. Perimeter. Fencing is talking about perimeter. Okay? When it says enclose, enclose is like a fence on the outside. So that's going to be your perimeter. So whenever you see fencing or enclosed, you should start thinking about perimeter. All right? Now, at the end, we're actually going to have to find out about the area, because that's what the question's asking about. So we have to be comparing two different things. So you need to write down, first of all, a couple things. What a rectangle is. So when you see something rectangular, well, what do we know? Well, we know we have two pairs of sides that are congruent. They're the same length. They're parallel, which is not going to matter in this problem, but you should know it. And as for right angles, that's also not going to matter in this problem, but you should know it. The key part is two pairs of sides that are congruent, which means their lengths will be equal. Okay, now, so what dimensions would result in the biggest area for this garden? Let's look at these. All right, I'm going to skip. I'm going to go from the bottom to the top. So I'm going to go from 4 to 1. So let's look at this first one. Actually, I'll go from the top to the bottom. Top to the bottom. All right, now, if we have 64 feet of fencing, all right, and the length and width are equal, if the length and width are equal, well, what does that mean? Well, that means that really our rectangle, if our length and width are equal, it actually is going to be 16, 16, right? 16 and 16. Because that's the only way that you're going to have a perimeter of 64 and the length and width being equal. So if they're all 16, the perimeter equals 64. The area, now that's the part I need you to write down here. Area is length times width. So when the lengths would be 16 and 16, our area would actually be 64. I actually need to multiply that. 16 times 16. Hopefully you have a calculator that you're working with, so you already have the answer. But it would be 256. All right? And let me erase this a little bit, make it a little neater here. And these will not be drawn to scale, what I do here. All right, so the perimeter is 64, and the area is 256. Now, what if the length is 2 more than the width? If the length is 2 more than the width, the only way that's possible is if you have these dimensions. If you have something like this. So if you have 15 and 17, and then that would be 15, that'd be 17. Now, if you add these up, you still get a perimeter of 15 plus 17 plus 15 plus 17 is still your 64. So your perimeter is not changed, but your area will. So your area, if you have this type of shape, would be 15 times 17, which would end up being, let's see, do I have that written down here? 15 times 17, don't have that written down. I'm going to go to the calculator and do 15 times 17, and that would be 255. Let's go back here. So that's going to be 255. All right? Now, what if it said, or what if the length is 4 more than the width? Well, the length is 4 more than the width. I'm going to draw that over here. The only way that's going to happen is if you have dimensions, and you should be trying to think of this yourself, but the only way that's going to happen is if you have 18 and 14. All right? Because if you add those all up, you still have a perimeter of 64. So your perimeter has not changed. However, the area that is enclosed has changed. You have to do 14 times 18. So the area is equal to 252, it looks like. All right, and then the last one would be 13, because it says the length is 6 more than the width, so that would be 19 and 13, which gives you still a perimeter of 64, but your area is equal to, it doesn't look like I wrote that down either, so 19 times 13, 247. So what it looks like is our answer is actually that when they are equal, that's the largest area. All right, you have 256 versus the 255 when they were 2 apart versus 252 when they were 4 more, when the length was 4 more versus 247. If you kept going, you could actually see, let's just say I had a rectangle like this, and this was 1, this was 1, and then you had 31 and 31. Now notice, the perimeter would still be 64, but the area would actually only be 31. So that would be a very small area for that amount of fencing. So our answer again is number 1. So make sure that you wrote those things down that I asked you to write down. All right, now moving straight on to number 9. All right. Again, we're talking about perimeter. Let's read the question though. It says the diagram below shows rectangle A, B, C, D with diagonal BD right here. What is the perimeter of the rectangle, A, B, C, D, to the nearest 10? Remember, perimeter is talking about all the way around. So make sure and write these down. All right? And so take a second to write those down, and I'll come back. All right. So looking here, it says what is the perimeter to the nearest 10? Okay, look at the information we have. Whenever you have a rectangle, the diagonal actually divides into 2 right triangles. Anytime you have right triangles, so right triangles, you should be thinking about either 1, and you're looking for a side, you should be thinking a squared plus b squared equals c squared, or SOHCAHTOA. One of those. Okay? Now, in order to use this first one, Pythagorean theorem, you need 2 sides. We don't have 2 sides. And in order to do this, we're going to have to come up with this side, this side, this side, this side. We're going to have to add them all up. And the only way we're going to be able to do that is if we use trig, SOHCAHTOA. All right, now, so let's look at, I'm going to outline this in blue. I actually did this in class recently, so it should be familiar to you if you were here. Okay, now, in order to find this question mark over here, which I'll now label X, based on that angle, that's going to be my opposite side, and we already know the hypotenuse. So that means that we're going to be dealing with SOA, or sine. So what you're going to do is sine of 30 is equal to x over 12. I put that over 1, then you cross multiply, and you have 12 sine 30 is equal to x. And when you go in your calculator, remember when you go in your calculator, it has to be in degrees. So I'm going to check to see, is mine in degree? Yeah, it's in degree. So I'm going to go back, and I'm going to do 12 sine 30, hit enter. So our answer is 6. So that means x is equal to 6. That means that this one is 6. That means this one over here is 6. Now we have to find the other one, which we can now find this one down here, BC, because it's going to be the same as AD. So we can find BC now. So now with BC, I'm going to use my given information, which was the fact that I knew the 12, and this is going to be my adjacent side. So that means I'm going to use cosine for this one. So cosine of 30 is equal to y adjacent over hypotenuse. So we're going to do 12 cosine 30 is equal to y. So I'm going to do my calculator, and 12 cosine of 30 equal to 10.39. You know, I'll do 10 point. Now we have to round our final answer to the nearest 10th. You know, you might not want to round too much now, but on this problem, I don't think it's going to matter. So I'll just round to the nearest 10th right here. And so it's y is equal to approximately 10.4. So that means up here is 10.4, down here is 10.4. Then we do 6 plus 10.4 plus 6 plus 10.4, and that all is equal to 32.8. All right. Okay, looking at number 10 here. A couple things here. Just make sure that you write down these notes here. Don't have much for you to write down. Let's go ahead and read this question. It says, identify which sequence. This word sequence, that means when you do something after each other. So like a sequence of events would mean that something happened after something else. So order of events, something like that. Okay, so now this is our pre-image. How do we know that this is our pre-image here? Well, it doesn't have the little marks like the image does. These little marks right here. Okay? So it says identify which sequence of transformations could map pentagon A, B, C, D, E onto pentagon A double prime, B double prime, C double prime, and so on as shown below. All right, first of all, one of these we can eliminate because the shape remains exactly the same. So we know with the dilation that doesn't always occur. So we can eliminate that. Let's look at the other ones though. All right. So could it be a translation followed by a line reflection? So the only possibility, so let's look at that. Could it be a translation? Remember, a translation is when it just moves. So could it have moved down and then been reflected over a line? Well, if it moved down and A moved here, and B moved here, and C moved here, if you were to then rotate it, the C is going to be in the wrong place, right? Because your C is going to end up here when it should be down here. So it's definitely not that. But maybe it got translated the other way and then reflected. So let's check that. Let's check that. So I'm going to move a couple of these things now. All right, so what if it got moved? What if it got moved this way? So all these points got moved this way, right? And then got reflected. Okay, well, let's look at number 2, first of all. Number 2, could it have gotten, if it gets rotated, if you imagine this thing rotating like this, C would be in the right place, but notice B would land right here, right? And that wouldn't be right if it got rotated that way. And if it got rotated the other way, you're going to have the same issue, okay? So it can't be number 2, all right? Let's look at number 3. Let's look at number 3. If you were to translate all these points, so let's just say C comes here, and D comes here, right, and B comes here, right, we're translating it this way, and then A comes here, right, and then E comes here, right, okay, then, hold on one second. All right, and if you did that, so I'm back, if you did that, you'd end up with this. And then if you rotate it, not rotate it, if you reflected it across this line, all right, the B would come and land on B prime, C would land, E, everything would land correctly, so that is our answer. That is our answer. All right, be careful, because if you did a line reflection followed by another line reflection, because a lot of students will see it and they'll think, okay, it should be a line reflection followed by another line reflection. So let's just look at that and see if that could be possible. So let's just say you reflected this shape. What would happen is B would land over here, D would land here, C would be here, and then A would be over here. So all these, and then E would be here, right? And then if you did another reflection, so this is a bad picture, but if you did another reflection over this line, do you notice how these do not match up here? And the D would be on B. That's not what we want. Now you might be thinking, well, what if you did the other way? So you went down first and then over. Well, let's check that out. Right, so what if you did this way first? Reflect over that line. So that would be A prime, E prime, D prime, and B prime. And then C prime would be down here. All right, now, if you now reflected it over this line, now your B is going to come all the way and land over here. Your D and your B, they don't match up. The only one that's going to match up is problem number 3. Not problem number 3, answer number 3. It's been a long day, so done with this. Hopefully you wrote down all the notes and you learned something.